Okay, everybody. Well, we're coming down to the last few weeks of the term, and oh, that's who we're missing, Nicola Hine. Yeah, he'll probably show up in a bit too, because he's going to be doing a presentation too in a couple of weeks. Um, First of all, if you can see the chat, Laura has posted a web page with a bunch of her stuff on it that you're welcome to go to, and I'll be putting this up, of course, on the web page probably tomorrow when I get everything arranged. And also I'll make sure to put links to some of her projects if they're not all there. I think they're all there in your sound
Yeah.
ad topics, right? Okay. Okay. Anyhow, let me just jump right in. Lara was just graduated this past May with a major in music, and she concentrated most of her last couple of years down here at the CMC doing various kinds of projects. She got very involved in SES class and took my Unity class and did quite well. She came into it. I didn't realize that she had such a strong background in computer modeling, but she just kind of knew Blender backwards and forwards. She showed me some of her
I
art, and I thought,
actually didn't.
"Oh, you didn't? Oh, you totally faked me out. You totally faked me out." This is how you get jobs, Lara, by the way.
That's
Just
how I've been getting jobs
totally
recently.
fake people out. Yeah, she impressed me. At first, I thought she was just like a flaky artist. Well, it turns out she is a flaky artist, but a good one. So, and she does just fabulously wonderful stuff. And she's going to show us some of that stuff. And she's gotten really, really deep into the technology, much further than I've gone in terms of things like, using Unity on the web, creating interactive multi-user things and stuff like that. You can also see some of her work, and I'll make sure and put this link in if she hasn't. She and a former DMA student at Columbia, Taylor Brook, just released a CD project uh, based on this book about, oh gosh, I forgot the name of the book.
Star Maker.
Star Maker, yeah, Star Maker, and it's just a wonderful project. We did kind of a little podcast about it, and Laura wrote an app that's just a lot of fun to kind of fool around with. But I imagine she'll probably talk a little bit about that.
Yeah.
And yeah, I'm anxious to hear what she has to say. I should also mention that she's already kind of burning up the stellar career pathway. She graduated from Columbia and won what's called the Arthur Sudler. It's the Sudler Prize, and it's kind of it's a pretty substantial honor that we give to our undergraduates. And she was most deserving. Everybody said yes, Lara. So anyhow, she's now living in Brooklyn, making her way in the world, and she's been doing lectures at Harvest Works and other places, and we're really happy to have her here. So Lara, it's all yours. Take over and show us cool stuff. Okay?
Awesome. Okay, cool. So I pasted a link where you can access all the things. You're welcome to wander those apps while I present and just type in any questions, and Brad will
Yeah, or yell them out,
around.
because
Yeah,
she'll be
yell
sharing
them
her
out.
screen.
I
Yeah, and
like answering questions throughout.
I'll try and monitor stuff, and I've got a few questions for her as the thing unfolds too. So
Okay. So the first project I'm going to show is the very first project that I created in Unity. And this is called Pregnancy Journal. In the experience, if you click on the web app, you can start wandering that now. You run into different colliders, and you just navigate with your arrows. And as you run into those colliders, it plays clips of, it plays like parts of an audio clip. And that clip is from my mom reading her pregnancy journal. So in this scene, what we have is a bunch of these different shapes. You'll see that my mesh is this like, can you see that other window? Is that appearing for you? No?
yes, it is.
Oh, it is? Okay, great.
At the one you just dragged over, right? The smaller one.
Yeah, the smaller one.
Yeah, that we're seeing it.
Yeah, so I have a bunch of these different 3D shapes, and then on some of them they have sphere colliders, and And the script is very, very simple. This is my first project that I did. So when it enters the trigger, then it plays the sound. You'll see that there's also more detail on the surfaces. And what I'm using are normal maps. So I'm going to stop sharing here. And
Yeah, you might. I have not explained what a normal map is.
yeah.
Okay, so
Sure, okay. So I have some links here. So on the 3D meshes, they are created out of, actually, you know what? I'm going to open up Blender because that's probably a better way of describing stuff. Okay. Okay, this is Blender. This is an older version. In Blender, you can create 3D meshes. So I'll add a mesh of UV sphere, and I can control what that looks like. And you can see that the mesh is made out of vertices and faces, basically. And so what I did to create those shapes is I modified these vertices, or this shape. And in these 3D modeling softwares, you have different sort of tools to change these shapes. And so I made the rocks by sort of sculpting that shape. So each one of these shapes is made out of these faces, and all of these faces are planes that are defined by a vector that goes perpendicular to them. So one common use of normal mapping is to create the illusion of a smooth surface. So if I go into the object right here, then where is it exactly? That's sort of what the smooth shading looks like in the software. Now, if I go to the Unity documentation on what normal maps are, it explains how normal mapping is used to create that smooth shading. So this is the actual data from the mesh itself, and then normal mapping interacts with how it is rendered according to whatever lighting is in that scene. So in Unity, they have a set of shaders that are already there. Can you see that? No, I forgot to share. So you'll see that when you create a material, you have various shaders that you can apply to them that come with Unity. For example, if it is an unlit shader, then you'll see that it doesn't have any of that texture. Normal mapping is a way of telling the shader how to, like which directions those fake normals for the planes will go. So you can create this illusion of extra texture. Cool. So one thing that I do is I make these digital collages, 2D digital collages in Photoshop. And so I made these collages out of photos of orchids. Like these are like the original images. My friend sent me a set of them. And I noticed that they have these like clear patterns that could be used in the normal maps. So let's use this one, for example. I made these textures out of pieces of that collage. And then the normal maps, I also made from textures just within Unity. So if you click create from grayscale, you can make these different, say, normal maps for texture. Yeah, that's pretty much it. And I'll just share the piece. Let's see. Ah, 2 screens. And share sound.
To me, it was dramatic to see our own baby so alive. To me, it was dramatic
She was really
to see
happy.
our own baby so alive.
So the idea behind this app is that as you are wandering throughout the scene, you are encountering these little messages from the pregnancy journal entry. And in this entry, my mom talks about this one time where she snuck in to use an ultrasound machine that was being developed to look at her own baby. And so I wanted to create an analogous sort of experience of wandering inside. Also, you cannot go outside of a certain boundary. That's also defined. Cool. That's pretty much that piece.
That's similar to how Nina set up her garden to prevent you from going outside the area where you're supposed to stay in.
Yeah.
You create an invisible barrier and you can't traverse it.
Okay, I was just gonna ask how you did that, but no.
Let me see how I did that. It's like a clamp distance. Okay.
So that's different than the way that I did it. I created like a rectangular thing, and then just made it transparent and made it a collider, so you couldn't go through it.
Yes, I could have made a few different colliders. Why is this not opening? Well, I'm just going to share the Unity project, and then you can see the code on the side. I'm going to make it smaller. So this is the movement that that Brad taught in class. And then there's this clamp distance here. So this is just a public float. And this is from
So what you're seeing is kind of the interior code of that observer move script
yes,
that I always have you put in.
script.
Yeah.
I have a question about the normal mapping. So when you have the those arrows that define the normal to the curved surface, is it like the surface will automatically be a curve, or is it just making like more and more little tiny segments, I guess?
The normal maps are, okay, let me just show one of them again. All right, this is what it looks like. It sort of looks like a bluish, pinkish texture. Do you see this like gizmo right here? With Y is green, Z is blue, red is X. Those are how the normal maps encode the directions of the vectors. So if it's like this amount of blue and this amount of green, then it will be that vector will be somewhere in the Y and Z direction. This is, the normal map is actually generated by Unity from the grayscale image. I don't know exactly how they do that, but
yeah.
But it's generally sort of like these like smooth, like these smooth like way of encoding sort of the direction and how the lighting is going to hit it.
I see. So that's like, it's not the actual, I guess like the actual shape is only the vertex.
The actual shape is defined by the like mesh. Mesh is defined by like those planes with those hard edges, and the normal mapping is just another texture that is like used within the Unity shader.
I see. Okay. Thank you.
To interact with the lighting. And so you'll see within this scene, I have all these little point lights. And so these point lights have a certain radius and intensity, and this is what is interacting with that normal map.
Yeah, Reina, you can think of it as deforming the mesh, and that's what the shader does. And the thing that makes it so efficient, shaders are just like monstrously fast. They're the ones that run on like those NVIDIA GPU cards and everything like that, so that you can work with a base model and you can apply all kinds of different normal maps to it to get different kinds of textures and smoothness or whatnot. And I think it does actually interpolate down to the pixel level. Mm-hmm. So that you're seeing a very smooth result. You're not going to see any, it's not creating more polygons or anything like that.
Okay. So the next thing I'm going to show is this series of apps that I called Violin Paintings. And in the app, oh God, my thing's unplugged. Let me just pull this up. In the app, you click and drag your mouse, and as you click and drag your mouse, you'll notice the sound change a little bit, and the texture is moving. So after making that pregnancy journal experience, I wanted to figure out how to then get movements on the texture and the appearance of like pushing something. Okay. So here we go. Let's get to this scene. So within this scene, we have a few things. This is a sphere with all of the normals flipped. So instead of having the planes face outwards or facing inwards, so when you're inside this sphere, it looks like you're inside. And then we have these procedurally generated meshes, which I'll talk about, and a bunch of these audio sources. So first, the procedural generation, just okay, here's a simple example of the mesh generation. I'll make it smaller so you can see it. This is basically creating six different planes, and then each one of them is the same distance from the center so that it looks like a sphere. And then on top of that sphere, I have some layers of smooth noise. So for the mesh generation, it all happens sort of like this. Basically, you create a bunch of different triangles. And so you define where the first vertex is, The next one, and then you just create a bunch of triangles for the size of the mesh that you want. And you repeat that along, like you do one row, and then you do the second row, and you repeat that over and over again. And so that is within this 4 loop. Then I also have a reflection probe at the center of this. So the reflection probe is defined by this like box, and everything within the box that you mark as being like captured in the reflection will be reflected at the same distance from the center. And so originally I tried this out with a sphere and did another tutorial on like the generation of these planets, and found that I could get that motion by using the reflection and then adding a force to the sphere. So as you click and drag your mouse, you are adding a torque to this sphere, and your camera is then a child of the sphere. So here's the camera, and as you rotate this sphere, then this will move and give that impression of that smooth movement. But this smooth movement is really a product of that procedurally generated like smooth terrain. And so I made some different shape settings. I followed this tutorial, linked it, and the tutorial basically shows how to change the Unity editor settings so that you can just adjust from here and look at it. So I can like create a different remove layers, for example. Well, that's not very happy right now. I'm getting a rainbow wheel. Okay. Let me share the mouse drag. So at the beginning, in the start method, I get the rigid body that is attached to this planet. And then it checks to see if I am dragging my mouse or not. And if it is dragging, then I get the position of the mouse in the X and Y directions, and then I multiply that by the speed, which is just to float, and then time. And according to how far my mouse is dragged in what direction, it adds torque, which is the rotational force. I also, let's undo that. Well, anyways. Oh, the audio sources. Let me just X out of this. So, I have audio sources that are placed around the sphere, and they're attached to, so the audio sources are attached to the sphere. They're all children of this one game object. And all of these audio sources have some sort of spatial settings that are defined by this curve. I'm using a logarithmic roll-off. And then I have a little bit of a Doppler level as well. In addition, I am changing the volume of the looping clips that are placed around the sphere, depending on how fast the thing is moving. So, audio snapshot manager. There we go. So I created a bunch of audio mixer snapshots for each one of these clips. And then if my mouse button is up, so if I finished dragging, then it gets the angular velocity of the rigid body. And if it is within these different ranges, then it'll change the volume and transition between these different states.
So then the audio source that you're closest to then will be taking precedence as the sphere
they will
rotates?
be taking,
I
so
see.
your audio listener is on right here. So the audio listener is the position from which those calculations are made. So that because this audio listener is also attached to this sphere that rotates, then, and these audio sources are static, then you are moving essentially along the surface of the sphere in different directions according to which direction you are clicking and dragging.
And then as you move, you encounter the different audio sources.
Yeah.
I see.
So they all have, so all of these audio sources have these roll-offs according to the distance. And so you can also set like a max distance at which you will hear this at all, and a minimum distance at which it will start to do the roll-off. So if you are within the minimum distance, then you aren't hearing any changes. Yeah. Cool. All right. So I also decided to, maybe I'll just share this for share sound. This is sort of what it looks like. And because this is quite quiet, but the rigid body has a certain mass, and so I'm applying that torque, and it'll eventually kind of slow down. But it's kind of tricky to to move this. Anyways.
Boy, it's funny. When I first saw that, I didn't realize I was inside a sphere. I thought you just had stuff scrolling by.
But you don't ever see that sphere because you're always looking down at So this
Laura,
is just the original. That's just the original painting.
question for you. Is that because Zoom is like stupid and ridiculous, it's not playing in stereo. Are those actually stereo audio sources? Can you hear them go by as you
Yeah,
kind of encounter them? Cool.
they're stereo. Yeah, and that's linked also if you want to look at that. Okay. So I'm now going to show the other project that I did with this procedural planet. Let me just open that up in the meeting first. So this project was for Taylor Brooks' album release with Talk. And it's based, the music and this app is based on a novel, a sci-fi novel written in the 1930s. And in this novel, this person gets like flung to different planets and encounters these different social creatures that experience the world in different ways, and they organize their societies in different ways. And one of the planets that is in the music contains these creatures that don't use sight and sound to communicate as much, but they use smell and taste. And so Taylor thought it was kind of appropriate in my style of art to make a planet that represents like encountering these creatures. So, and with a similar method that I used to like create those 2D collages in Photoshop, I made another version of basically the violin painting. Find the scene. Taylor Gross Terrain. That's what I call it. Here we are. So this is what this looks like. And I made a digital collage in Photoshop for this image that is reflected. And instead of moving around the planet by dragging it around in a circle and looking down at it, I decided that I wanted to be able to experience the planet from like the outside. And so I made this ball that bounces along the surface of the planet. And on these meshes, I put mesh colliders so that the ball will hit it and you can move the ball along the surface. So let me just show the code for what's going on. There's basically one thing called, I didn't change the names of from the tutorials that I followed, but there's this ball. There we go. Let's show it. That's just appears red, so it kind of looks like a dot. And it has a script that basically applies gravity from the planet. So as you move along the planet, you experience like resistance as you go up and down the terrain. So in the update method, I check the inputs. So I either your arrow keys or WASD, and it also calculates the direction from the this ball to the center. So that's what this is. And then I add forces to this rigid body, depending on the inputs. Yeah. And so let me show the gravity. Okay, so this is the gravity script. I have the gravity script on here. And so you'll see like this public variable here is just assigned to that rigid body. So it gets that rigid body from the bird right here. So it gets this rigid body and it adds a force in the direction of the planet. So let's play a little bit to show you what that looks like. So as you go through this app, these buttons appear in the bottom that define how your camera follows. I actually should show that too. And you push the ball along the surface. Also, all of the
One
fun.
night, when I had tasted bitterness, I went out
You hear
onto
that?
the hill.
Yeah.
Dark
Yes,
heather checked
we're hearing
my
it.
feet.
So
Below
I'm
marched the suburban lamps.
using my keys.
Windows, their curtains
Then-
drawn, were shut eyes. Beyond the sea's level darkness, a lighthouse pulsed. Overhead obscurity.
So that's how that works, basically. Let's go back to the project. Okay. Here we are. So we discussed the reflections and the movement of this thing. In addition, you heard the sort of percussion clips. So let's see. What did I call that? Ball percussion. Okay, that's the script for this. I'm going to make this smaller. Can you see that now? Is that fine?
Yeah.
So, I am taking this clip and it chooses randomly, or like I'm just using a switch statement to choose between these different points in the clip every time that the ball hits the planet collider. And so here we go. So, so it decides the start time in the clip, and then it fades from that time. So while it is playing and it is less than the duration of the clip, then it does a linear interpolation between the like start volume and end volume. In this case, I'm just starting from the full volume fading out.
Larry,
mhm.
I've got a question for you about, especially, playing these clips and everything like that. I mean, given that this was an app, a Unity app that you made for the web, did you have to be careful and clamp how many clips you might have going at the same time? Was that becoming an issue for you at all?
It didn't become an issue. The issue that I ran into almost immediately when I started making stuff from the web is the amount of time that it takes to load the app, because most people will sort of click away if it takes too long to download all of your assets. So within the scene, I have defined certain times that different assets are loaded from my server. So at the very beginning of this app, the only two clips that are there are this like cricket sort of sound and the crow sound. And then throughout the time when you are in the app and between different scenes, it loads in the clips.
Clever.
Yeah. Okay, I'm gonna just continue with this. So you start at a certain time, and it also gets the collision information. So it calculates this float value of the magnitude of the collision velocity.
Laura, before we leave the app loading stuff, got a question from Alessandra Urso, wondering how you stipulate which assets get loaded first in the order.
Sure, let's just do that. Load sounds from server. Okay. So I have let me just make sure which one. Let's see. I'm gonna try to open this.
Yeah, I also noticed, I mean, Unity's tried to get around that because they allow you to compress your assets. But for some reason, when I was compiling for the web, I had to turn compression off because none of the browsers would decompress properly.
Yeah, they won't decompress your audio files. And so that was my main problem with loading those assets, is that those WAV files are much larger. So I don't remember I put this. Okay, I'm using Unity Web Request. So basically, I have a link to the documentation for that, but it checks to see are certain of the assets already downloaded or not, and if they're not, then I retrieve this asset from the same domain where the web app exists. So for me, that's on lar.world.
Are you running this this kind of loading script continuously in the background, or are you waiting for specific points when it does the loading?
The loading happens when you move between the different scenes. So when you click the button, it will load those different assets.
Got it.
So like here are these different URLs that I just input as strings, and then it will get that certain type of asset depending on what you say here. And then I also have another clip I have another script, sorry, that will change the text that you see as soon as one of those items is loaded. So when I was talking to Taylor about like how to do transitions between scenes and how to maximize the amount of material that can be used, we decided that we could use that as a way to integrate the text into the experience. And so I have this function called change text that is on a different script. Find that. Okay. Yeah. All right. So first, for each new scene, it'll change this static variable of items that need to be downloaded. And for each item that is downloaded, then it'll increase the items that are already downloaded. And every time that one thing is downloaded, then it will change the loading text. And so I just have this array of different strings that will show on the canvas, or it'll change this text right here. And so I just have a UI canvas and this loading text. Yeah, does that make sense? Okay. Yeah. And then in here, I'll just share maybe that. Project one. So you'll see that once the files are cached in
One
my
night,
browser,
when I
then
had
that
tasted
takes a
bitterness,
lot less
I went out onto the hill.
long. And when you go
Dark heather
to
checked my
different scenes, all it's doing, it's not actually changing scenes, so that everything within the scene is the same.
I had always supposed that humans were unique beings. An
In
inconceivably
this,
complex
get
conjunction of
close section,
circumstances had produced them.
my camera is very close to it, and I've
Yet
added
here,
just
on the
rotation
very first globe to be explored,
to that planet shape.
his head.
Okay. Cool.
I think one of the things that I enjoyed about that app is that a lot of times it's not actually obvious what's happening, you know, when you're moving and things like that. You don't make it like a gamer's sort of thing or anything like that. And that really creates a very different sort of experience of it. And yeah, it's one that I think is actually pretty cool.
Yeah, the movement's a little, it was a little bit awkward when I first started to try to figure out like how do I move the camera in different ways and create like different scenes just with how the camera is following. And I enjoyed that kind of like awkward experience of like not really understanding how to move the ball until you see the planet in a bunch of different perspectives and can get a sense of like what the terrain actually looks like. Yeah. Okay. So a project that I started in January last year, my Dollhouse project. So okay, January last year, after making that cave experience, I wanted to figure out if there was a way to recreate real life spaces in VR. Oh, thank you, John. Okay. Let me share my screen. Okay. So I started working on this dollhouse that I started when I was like 11 with my dad. And this is what it sort of looks like. I installed from floor to ceiling is about 8 inches, and all of these little lights are working. And oh, I guess I don't have the picture, but there's a bunch of strips of copper tape, and I just installed these tiny little bulbs and filled these spaces with just things that I collected in my childhood. So like these are little rocks that I used to have, and these I used to like love taking things apart and putting them back together. So I made little chandeliers and ripped up some of my kind of old unfinished paintings and put them on the walls and on the floor. And I borrowed a 360-degree camera. This is the only picture I have of it. This is what it looks like. It takes, every time you take a photo, it takes 6 fisheye photos. And this is what one of those fisheye photos looks like. And then I used stitching software to put together these 360 images. So this is sort of what one of them looks like. If you want to come join the Dollhouse, click on the link and I'll see you there soon. All you have to do is connect. Okay, so I made this scene and this is what it looks like with my mom inside, the chandelier. Oh, this is what the copper tape looks like. And so the circuit is just connected with these tiny little brads that connect them from one end.
Tiny little brads?
Tiny little brads. Brads meaning those tiny things. Yeah. So, I got really lonely at the beginning of the pandemic, and I wanted to find a way for other people to like create a space where other people could play. And I started thinking about this idea of a community dollhouse. And so I sent out this like kind of really intimate invitation to all of my friends and said, you can forward this to anybody. Basically asking for anyone to contribute any sort of digital file that is either laying around or if like someone wanted to try experimenting with something new. I also offered like little mini lessons on Unity. And so, is anyone here? Hi!
Hey, Laura, could you repost the link in the chat for people to click on? For the
Sure.
It's just lair.world/dollhouse.
Do you think you could do that? It's dollhouse.lar.world/gallery. Okay. So in here you can see other people who are connected. Everyone is represented as this egg, and you wander through different rooms. And as you go to different rooms, I'll open up the Unity project in a bit. You load those different items that people have contributed, which are just stored on lar.world. And there are different scripts that are activated when you enter different rooms. So let me just share that. I'm gonna exit out of here, so be nice in the chat. And I'll show some of that, how those connections are made. And basically, I have a client application, which is running on your web browser, and a server application, which is running on a virtual Linux machine. And I'm using this cloud service called DigitalOcean to host that server. So let me just open up
Yeah, we'll have some questions about that, but I want you to show the dollhouse first, okay?
Yeah. Let me just open up what the scene looks like. So at the very beginning, when you connect, you'll see that all of these rooms are like, aside from these 4 rooms that are directly visible at the beginning, none of these rooms have any textures on them. All of the audio sources are like, all those files are on my server and just accessed through the URL. So this is what the client looks like. So at the very beginning, you connect, and this is this connect. You connect when you like press that button connect. It checks to see if you have inputs and text as your name, and if you have, then you connect and you set your player name as whatever you've entered, and you are assigned a unique ID. So everyone who connects is given a different ID, so that we can determine like what sorts of messages that you are sending. So you're sending different messages to the server, and then the server sends the messages back out to everyone else. These messages, I basically have just separated into different parts. And so there is a message that you've connected, for example. There is a message that you're sending for your position. And also when you send a chat message, that's a different kind of message that you send. And these are sent as long strings. And within these strings, I have certain characters. So it's this character that separates the different parts of the message. And so, for example, for the position messages, these are sent every 0.5 seconds back and forth. You send your X position, your Y position, and your Z position. And so everyone in the scene, every 0.5 seconds is updated on that. The chat message is similar, but there are different types of messages that are like always sent, or sometimes like certain types of messages that are not required. So for the chat messages, I have that secure type of message, and for the position, that's or I forgot what it's called exactly, but it's like reliable and unreliable messages. And that's pretty much it. I mean, it transforms the position of those avatars, which are prefabs in Unity, for everyone. And that's pretty much how it works. Yeah. Sorry, do you have any clarifying questions?
Well, I know
I didn't describe that very well.
well, it's so dense, you can't just sit and describe it. You know, you really have to kind of experience and really look at what you've done and accomplished in the code and everything like that. One of the questions that came up though in thinking about compiling for the web is what kind of a hosting situation should people look for in order to make this stuff run? Because I know you went through several iterations before you found DigitalOcean. Maybe you could talk a little bit about what was important and what you tried.
You can also host, well, originally when I was trying out just what to see what the web apps look like, I uploaded my builds to simmer.io. I don't know if you've showed
Yeah,
that at
I was going
all.
to ask about that. That seems to be pretty popular. I saw that in a couple of the instructional videos, that they
Right.
just kind of sit there and you can just upload your Unity project and then it'll give you a URL and you can run
Yeah.
it.
The reason why I needed to host on my own site is because I am doing those requests for the assets. So those have to be on the same, they have to have the same origin as the web app. So I can't access resources from other domains, for example.
Is that a security issue then?
That's a security issue.
Got it.
Yeah. Yeah, so within the scene, there are colliders for the walls that prevent you from going, into these areas, but then you can pass through the windows. And then colliders that are marked as triggers as you enter different rooms that will start that loading process for those different assets that I want to bring in, and also enable those different interactive scripts. I also, let's see, what else should I show?
Before you leave the dollhouse, another question just about efficiency concerns.
Mm-hmm.
Did you have any trouble hosting many people? Did it tend to get bogged down if too many tried to log into it? Do you have to restrict that at all?
Yeah, so I ran a series of tests every sort of like week and a half to see how to optimize that client application, because if it's I found that like it would it would disconnect more often if just the app crashed somehow. If too many scripts were running at the same time. Yeah, I mean, I ran into problems, but I was never really sure which of the problems had to do with people's machines or their internet speed, or I don't know. It's tough.
It must have been really fun to debug, I can imagine.
Yeah, I did the debugging throughout the period of a couple months, and that's also why a lot of my code is kind of like it's kind of haphazard, because I started with a couple rooms, and I built this structure of this outwards as people were contributing things. And so I have contributions from like about 35 different people, and I'm just trying to manage like how many things can be loaded at like within certain rooms, or which scripts are more taxing on the CPU. For example, there's one room where the walls are lottery tickets, and as you click and drag around, you can scratch. And in order to scratch, I wonder if I can find that script to show you. That is in the room, enable scratch. No. Where is this? here's the script for that. So I'm actually creating a mask that doesn't render that layer within a circle. So I create a bunch of different circles, and this really slows down the application. And so I just try to keep certain scripts like contained within the rooms and not running all the time. But yeah, I don't know. Ran into a lot of difficulties as I was building, because the way I organized is just outwards as people were contributing. Okay, so after creating the Dollhouse gallery space, people were like, "Oh, we should have a party." And you can't really like spend that much time within the gallery space. And I also wanted to be able to, have a concert within the space. So then I created a Dollhouse performance space, which has these textures on the walls to which you can stream video. And let me see if I can find some of that video. So basically on this opening event, 13 different people streamed video from OBS, which is a broadcasting software, to a channel that I created in Amazon Web Services. And this channel basically encodes the video to a format called HLS. And what HLS does is it takes these 10-second segments of the video and then sends them out to everyone. So you're listening to like 10 seconds at a time. So this is what Amazon Web Services is. DigitalOcean and Amazon Web Services are both different cloud services. DigitalOcean is, I think, preferable for like small applications, and it's the pricing is good. That's why I sort of decided on that. Amazon can be a little bit pricey.
Yeah, they're all basically running like a Linux shell, right? Because I use Linode, and that uses Ubuntu. But then you just like set up your HTML on that, correct?
So Amazon Web Services has this, like, I didn't have to do any of that like video encoding. What I set up is a channel, and then in the broadcasting software, you can stream to this channel. And then this channel goes to the WebGL texture using an asset that I found. Yeah. So I want to share a little bit of the performances. Some people played with the latency. So I want to show this example of my friend who had the Dollhouse application open at the same time that he was playing, and it takes about a minute from the streaming software to get the video from the streaming software to my channel, and then to the Dollhouse, because these servers are in different locations, takes time. And so there's about a 1 minute delay between when you are playing your instrument. And
Yeah,
when
we discovered this when we created our own little internet radio station. The latency is just insane. First, I thought it wasn't even working, and then you hear your voice a minute later and go, "Oh, it is working."
So he's just layering with the app open. And in this performance space, I have 4 different rooms. There's this, we're in the sphere room right now. There's a room where you can like see it at the screen. And I want to, there's a really fun moment in the very last set when everyone started dancing with their little eggs. Let me see. We don't have access to real spaces where we could dance with people, and so it felt like a little sweet thing to do. Yeah. Now that I made the Dollhouse chat, I also wanted to find a way to use it in a different way. So in April, I did this improvisation where I on Facebook Live, where I selected the text from the live comments, and I used a Chrome extension that does text to speech, and then I sent that text to speech audio and like audio from a microphone into a live convolution patch in Max. And so it kind of sounded like my violin was speaking. Let me just show a demo of what that looks like when I was just practicing and like selecting an email message from a while ago. So the types of sounds that come through are like these more consistent noise-filled sounds because of how the filtering works. Convolution is similar to like multiplying the frequencies. So certain ones will be more emphasized than others. So after doing this improvisation on Facebook, someone approached me and was like, "Oh, we would love to have like a piece for a live online performance of this." And so I, instead of like making other people do this like clunky action of playing your instrument, selecting, using the Chrome extension, and dealing with all of that stuff, I decided I just wanted to use my Dollhouse chat, and then also made another application for the text-to-speech that would receive those messages as soon as they were sent. So if I have both this open and let me just go back to that. Here's the text-to-speech. So anyone who types in the chat, go ahead and type. You know. First.
Hi there.
So it'll play immediately, and then they're sending audio from this into their Max Patch and have different controls so that they don't necessarily, like, just in case people aren't sending messages all the time, they can loop it, they can change the rate and the pitch, and so I'll show a little bit of that performance. This is with a saxophonist and a guitarist. In order to prepare for this, I sort of gave them like coaching on how to speak through the instruments, so that you can understand the words, so that it's legible and also expressive, and throughout, like, diverging from legibility and like making different sort of weird sounds.
Everything is so microwave. Fridge. Fridge. No. I'm sorry.
Yeah, so they don't get any sort of warning about what sort of words are coming through. I mean, they have control over what words are said, because if they don't play, then it will convolve with nothing. But the experience of playing this piece is like you are presented with whatever words people want to say through you, and then you have to sort of figure out, like, in the affect of that speech.
I guess it doesn't really matter in this application, but did you encounter any latency problems with the audio and stuff? I guess you wouldn't even know, actually.
This is actually, it was really fast. Those chat messages, like, I feel like as soon as I pressed enter, I would, like, hear it. And there's also this like group, like creating sound as a group as well.
Yeah,
because if you send a message and someone's message from before is still being said, it'll get cut off, and it'll just immediately say whatever message is the last one.
I like the group dynamics when they all started doing, like, what and all this stuff like that. It's pretty amazing.
Yeah, that was fun.
I was wondering, yeah, can I ask you about this? So how did you said they had some control over the chat, over what they
have So they have their Max Patch open, and then they have that text to speech app open. And that, here, let me just show that one more time.
So they're sending it on their own computer, like.
Can you see that? Yeah.
Max going into.
So they are, yeah, they're sending their sound through Zoom. So this is just for like a Zoom performance. But this is where the Dollhouse messages are received. So they get some sort of message, it is played right away. They can choose to loop it. They can choose the rate of the text to speech. And they can choose whether they're playing their instrument and what sort of sound is coming through. But they cannot control when the messages are received.
It's cool. This could be even bigger. I mean, it's already really interesting, and but it could be like a whole orchestra of people.
Yeah, it could be a really, really hectic performance. And I think it would be kind of cool to be able to sort of separate the messages in ways too. Originally, I was thinking maybe like both of them are receiving different streams, like maybe the audience members are like placed into groups.
Or one could activate and the other one in another time, and there could be two at the same time too, but be more like instrumentating.
Yeah. What should I show? Shaders. I have a lot of shaders, but I have 20 minutes. So
it's up to you. Go wherever you want, Laura. This has all been fabulous. So I'm happy with where you want to take us.
Cool. Let me just show the shader that I made yesterday.
It's a pretty cool shader, I gotta admit.
It's a pretty cool shader. So I have been like I'm sort of interested in the same kinds of motion across. Like I like organic motions. I like sort of motions of water. I like shapes of like plants. And so I've been trying to find different ways of either modifying those normals or the vertices. And so I'll just show an example of a shader that I made that is kind of has a similar effect to that like procedurally generated terrain. But instead, it's all done, instead of doing it in C#, it's all done in this language called CG program, which has like HLSL in it. Okay.
Yeah, the class webpage is going to have a link to some good shader tutorials because it's pretty intense stuff, but it's pretty amazing what you can do with it.
Yeah. So here I just have, a rug. Wait, let me show the rug. So I've been making some rugs, and I mean I can take pictures, right? I can't like actually bring this shape in. Like there are some phone apps which you can use to like scan a 3D object and make a mesh out of it. But I would rather not store that much mesh data in something that runs on the web. And so I've been trying to find different ways of just using textures to create all the detail and motion and interest. And so I was interested for this one in making a motion that kind of looks like you're moving the rug, and the fibers are moving independently. And so let me just show what it looks like, and then I'll attempt to open it up and describe what's going on. So this is what it looks like. The vertices of this plane are moving, as you can see. And it sort of gives the appearance that these fibers are moving. Yeah, that's what that looks like. And it has a very similar kind of effect to, in my opinion, to the like moving along the procedural planet. Okay. So the tutorial that I did, let's change this to a different shader. It is. In the tutorial that I did, you can see that there's like a center of the shape. So it knows where the center of the mesh is. And then there's this like cosine or sine wave that is moving the vertices. Like it's adding that sine wave over time to the y position of the vertices. So let me just open up one of those. Okay. So these are the properties that are visible within the editor. I have this texture and wave amplitude, which is a float. Okay, so the shader is structured in a few different, well, for the unlit shaders, there are multiple parts of them. There is data about the mesh, about these vertices, and there is a fragment part of the shader, which is here. So first, it for each one of these coordinates, so U, V are the coordinates that are on the mesh. It oh my god. For each one of them, they have a distance towards the center of the mesh. And then it I have another float for this wave, and this wave is added on top of those UVs, or it's and that varies the like motion of the vertices. In this other one, instead of doing the calculations mathematically, I am sampling from texture, sort of in the same way that like the normal maps, I'm using a texture to define where those normals are. Yeah. I don't like know enough about this to like talk in detail about it, but I just wanted to show the like similarities in the visual effects that I'm trying to get in different ways, and like finding the like most efficient way to get the same kind of motion that I want.
What these shaders are doing, and I may be wrong about this, is basically it's just like this hugely fast thing where it goes through like every pixel and applies this operation to it. and you're defining what Lara did was define what that operation was in terms of displacing, and
Yeah.
it just blasts it out as much as possible. There's always been people who've been trying to use the shader technology to do stuff with audio, but unfortunately, the big bottleneck with shaders on the GPU is actually sending the data to and from the GPU. And when you're doing it like as a batch like this, it works really well. Audio requires that you have kind of continuous flowing in and out, and that's unfortunately kind of slows it way down.
Yeah.
But yeah,
I do have a shader in one of the Dollhouse rooms that passes like information about like where, or information from like a C# script. So for one of them, I have actually I can show an example of this on my simmer. In this example, I'm doing something called Braid Casting, which basically makes a ray between like where your mouse is and that direction in 3D space. And it collides with a collider. And at the place where it collides, then something happens to the shader. So I'm going to put file on the screen. I think this is it. Yeah, this is one of the first iterations of things that I did with the Dollhouse. Oh no, this is not it. So this is it. So there are a bunch of these different meshes that are rendered as transparent unless a ray cast hits it. And then when the ray cast hits that mesh, it renders the mesh within a sphere around that. So like if it's within a certain distance, then it'll show. And so then I can sort of get this effect of like sort of looking around with my mouse. So yeah, that's an example of like the mouse. That is done in C#, but the like actual like rendering of those like surfaces are done through shaders. Yeah. Cool.
Artoon's quick with the hand claps, much faster than I am. Good for him. There we go.
Cool. Should I open it for questions? Oh, thanks for all the positive affirmation.
Yeah, we've only got about
it.
10 minutes left, so you've used up all the time, and it's great stuff. Yeah, anybody have any just general questions or specific questions even for Lara? I should also mention she's very willing to help people because she's a very helpful person. So, you know,
yes,
if you're interested in this stuff, yeah,
you can email me. Here's my email. Don't use my Columbia email anymore. Apparently it's gonna go away.
Yeah. It takes a while though. Like my son's email at Columbia was active for like 2 or 3 years. It was bizarre.
Oh yeah.
Yeah. But it's better to do that.
Oh, also, at some point I'm going to clean up my Dollhouse code. But I just put it on GitHub as it is right now. So if you want to go dig, then the link is there.
Wow.
And you can use whatever. I don't care.
Great stuff. Yeah, I think it's remarkable how you were able to kind of figure out sort of paradigms of interactivity on the web. You know, and it's interesting. I'm kind of glad you said it was motivated by just your feeling of extreme loneliness, because facing this COVID nonsense has been taxing on everybody. But
Yeah.
hey, you took a you took a you took a bad situation. You took lemons and made lemonade out of them.
I mean, there are a bunch of like interactions that happen on the web that do feel very intimate, and there are like ways of expanding on that intimacy.
Yeah.
I think the improv that I did on Facebook with people's comments and like that felt good.
Yeah.
Because we were like, oh, like we can only send text, but like everyone in this group that I was streaming to wishes that they were in the same space and like able to contribute to like the sound that's being made. And so it's been like that, and then like I was interested in doing the multiplayer thing, just because I like the idea of like being able to share like a play space with other people. And that is just like a shared dollhouse where like you can put your old stuff in it, or you can like play with something new. And then like people, I said you can like forward my email to anyone else who wants to contribute. And so I got some messages from people who were like, oh, I just saw your thing on the web. Like, I want to put something in it.
Wow.
And I didn't say no to anyone.
Huh. Have you had any bad actors or trolls or anything like that? You haven't had to deal with that, probably.
No, I haven't.
Yeah, that's good.
Been dealing with like 13-year-olds on Fortnite or anything like
Unfortunately,
that.
I think some of those 13 years olds are like 50 years old, and they're just like stupid idiots.
Yeah.
Yeah.
But I don't know. I like trolls. It makes the like I like the trolling in like situations where it's like a fun, playful thing. Like the types of messages that people are sending can really be anything, and I like that like idea of like the performer like not being able to filter and just having to like deal with whatever is thrown at them.
Oh, you young person, you're so optimistic. Oh, it's great. It's really wonderful. Wow.
I remember one of your first Dollhouse openings, like really early ones. Somebody started putting some things in the chat, and we were like, well, my parents are here. So
Oh, right. I invited Maya's daughter, I think.
oh, okay.
Yeah.
Oh, okay.
A really young girl.
Daria.
But I wanted it to be like a Daria. I wanted it to be child friendly because I love when children see my work.
Oh, there is a question for Henley.
Oh, yeah, question.
Oh,
He's just saying, yeah, it's really
he's
nice.
just being really, really nice to me. Thank you.
Not a question. Sorry.
Yeah. No, your stuff is really impressive. I like people to see it. That's why I ask you to do this all the time. So, no, I really appreciate it, Lara. Anyhow, yeah, we're about out of time, guys. So I think I'll go ahead and shut the recording down here. And yeah.